3D printing technology allows you to make hundreds, if not thousands, of publicly available puzzle designs. If you're interested in puzzles, it may even be a reason to buy a 3D printer if you don't already have one. So this video goes through the process that I use to make puzzles that are available on a commonly available website. It's broken up into chapters so you can skip those chapters that you might not be interested in. The puzzle I chose was one called Neighborhood. It's a design from 2013 by Stefan Baumegger. He has a Facebook site called Puzzle Leisure that he sells wooden variety of these puzzles. I encourage you to check it out. We'll take a look at that. So when we're building them, there's a bunch of steps that you need to go through. Where do we find the parts? And once you have the parts, how do we put them inside a cube? How do they align? How do we model these? We could use a number of different CAD programs. I use Fusion 360, so I'll quickly go over how I do that in Fusion 360, and you can adapt that to whatever CAD program you use. What slicer settings I found work well, and I do have a solution for this one if you absolutely get stuck. Remember that these designs are all copyrighted by the designers. So Stefan has generously put this on a publicly available website. Don't sell it or post the design files anywhere or give them to others. He has a great Facebook site, and you can buy wooden versions of his puzzles directly from him. This is his website. Amazing work that he's done in wood. Probably the best known site for getting puzzle designs is a site called puzzlewillbeplayed.com, and you can look up, there are hundreds, thousands of designs there that designers have made publicly available. So these are pictures of the 6 parts and the cage, and just by looking at them you can model these in almost any CAD program. One of the things you can't get here though, if you want to build your own puzzles, you don't know how these parts line up inside the cage. That can be an issue. So after several hours I determined that this was the orientation of these 6 parts, and it does take a few hours, if not days, to go through various permutations to try to come up with the right combination. So this is my version. You'll notice I've got some lettering that's in 2 colors. I'll show how I did that in the slicer. I even added some graphics. I like making a removable top because I can load the parts in, disassemble it, and not have to learn how to assemble until I really master the disassembly. I just use M3 screws, and I screw directly into the plastic. I also have heat inserts that I use. I'm going to show how these parts are oriented. If you want to build this model, you have to get these oriented exactly in this direction. And I had this part flipped, and there's no solution when you flip a part. So this is the process I take to assemble this puzzle. Some of these are much more difficult to fit all the little pieces together. The skinny white piece is easiest to assemble last because it just slides in through that gap. And then once you have all those assembled, you can just drop it in and screw on the top. Now from there you can see your puzzle should work similar to this. This is a nice size. I am glad I did make it 12mm voxels. They slide really nice. So fairly large. It's 7 voxels by 7 voxels, so it's 84 millimeters on a side. I used a parametric design, which means I used some variables. So if I just want to change the size of the entire puzzle, just need to change one variable. Removable top frame, really recommend doing that on these types of puzzles. And I specified an inset, which is shrinking each of those parts just a little bit so they slide effectively over each other. And the inset will depend on how well your 3D printer is tuned in. So your inset may vary from the number that I use here. So the first thing I do is create a parametric design. So you can see here I've used a bunch of variables, burrs, the voxel size. I have 3 different bezel sizes, small one for the parts, one for the face or the edges, the faces of the part, and a large bevel is for the frame. We'll see that a bit later. Each of these is its own component. In Fusion 360, you could make all these bodies under just the name of the part, but you should have it broken up into components. So what you'll see here is I have a frame component, the piece A and E, which are the same color. I do 2 pieces in one component, and then 2 more components for the other 2 pieces. So the first thing is to get a grid that these parts are designed on, and you'll see that my grid is based on burrs. I don't put just 36 millimeters, it's 3 times burr, so that if I change that variable, everything will resize properly. So every dimension that you use here should be in relation to the variables that you use in the parametric design. So fx means it's a function, it's retrieving a variable. And basically it's got 2 layers, so I've extruded down 1 burr size, or 12 millimeters in this case, to get the first layer. And the second extrude that you'll see here is for the second layer. So you just build each of those parts as you see them in the pictures. Although that says 12 millimeters, it'll say 1 times the burr size. That's what it's stored internally. Then we need to offset all the faces. So basically you use the offset feature and you just highlight all the faces. No, they were highlighted, so now they're not highlighted, so I need to highlight them again. Let's draw a little loop if I do it correctly. Highlight all the faces, and I'll use a minus inset. That is, I'm making them smaller by that inset amount, and I use 0.05 millimeter. As I say, that will vary depending on your printer. I then highlight a lot of the edges individually, and I use the chamfer to make a 45-degree chamfer on each of the internal edges, and I'll take a look in a second here. So my variable for that's called small bevel. Now you'll see on some inside edges I don't use a bevel. I use a bevel on what I call outside edges more than 90 degrees. But on the inside I don't use any chamfer there. So I didn't use one there. I didn't use one there. And I didn't use it on the face because I'm going to use a different size bevel there. So these are going to make a small bevel. And you can see what a small bevel sort of looks like in scale there. Now the next thing I did was bevel the face with a little larger bevel. That's just for aesthetics. I think it makes the piece look better as you're using it. Now it may happen that depending on the geometry of your piece, you may find that if you highlight all the faces that you get an error. And that error can occur if a face is pulling away from something it's connected to. Now, there's no example on these parts, but if you have that, a face that pulls away and actually makes a gap, Fusion will give you an error. It doesn't know what to do. So instead of using the offset on that particular face, you can extrude that face smaller. And then when you can use the offset on all the faces except that one because you've already making that smaller. Now that's a little difficult to go over here. I just want to mention that in passing. So you would use the extrude command. You'd use the same minus inset to make that smaller. Now I'm just going to cancel that because I'm not going to do that here. But be aware you could potentially get an error when you highlight all the faces of a more complicated part. And you'll have to deal with those. You'll have to find which faces are causing the error and use the extrude command. Now we'll look at the frame. You make all 6 pieces the same way. And with the frame, you're going to start, here's the timeline down here. We're going to start by just making a box or a cube. And you'll notice that 7 of these, I should have called that voxel, but I called it burr. 7 cubes in each direction. And after that, you need to hollow out the cube properly. And all those dimensions are multiples of the burr size. And then extrude that hole. You have to do that 3 times. Using shell for this design isn't something that's easy to do. This is just as easy, if not easier. Now, the inside of that box is not exactly the way it should be. I need to do 1 or a 4th extrude that you'll see here. And as I flip back and forth, hopefully you'll see the difference. Now, when I do this extrude, I'm not doing it, I've drawn it on the top surface, but I've started it 1 burr size down. So it actually starts 12 millimeters down from the top, and it goes down 4 more burr sizes and sort of hollows it out using that outline. You can see that here. So right there you'll see that the inside has been sort of hollowed, and you'll see that that follows the design on the website. Then I add some chamfers. I use this small bevel for where these parts will slide in and out. And on the outside, I use the large bevel, and you can see that the outside of the box now has a much larger chamfer. And where all the edges meet on the outside, you've got 3 options of the corner type you want. There's one corner type, which is a triangle, where the 3 edges meet on the outside of the box. You can use a miter, and I chose to use a blend. That's just, again, just aesthetics, whatever you choose to use. Again, I don't chamfer the inside edges. You'll see that on the inside there. Now, you shouldn't print this as one piece, because even with supports, the top walls will droop, and so you should cut it. And what I've done here is I'm splitting this body into 2 using this face right here as my splitting tool. So that will be the splitting plane, and it will break this up into 2 parts, a top and a bottom. And this also allows me to put in the screw holes. So if I were to just look at the bottom, you could see where I add more detail. I've also added some text. So you just pick a face, add text, and then you extrude it inwards. I extruded inwards about 0.6 millimeters. So I use the name of the puzzle on one side, on one sketch, And I used the designer's name on the other side. I even added some SVG graphics for little houses to go with the neighborhood theme. All of this is extruded inwards or cut into the surface so that I can use different color filament. Now here on the bottom part, I added some screw holes. I added 4 here. On future designs I just do 2 on the diagonals. 2 is probably enough. And this will show the size I've used. So what I did was I draw a sketch line from the center of the miter inwards, and at the center of that I draw 3 circles. So one, I'm going to use a 3mm screw with, it's got about a 5.5mm head. So 3.15 is so the screw will slide through. The 2.7 is where the screw will screw into the plastic. The screw's larger, so it'll cut its own threads. Then I have some registration marks. I use the slot for that. And you'll notice that I have 2 slots in different orientation, because it may be that your top is orientation specific. There may be something in the top that's not symmetric. So by having these registration points out of kilter a little bit, it can only go, you don't want it exactly symmetric. You want it to only go one way. So here are the screw holes in the bottom that are 2.7mm. So the 3mm thread will screw into that and cut its own thread. And you'll see up top these are about 3.2mm, so the screw just slides through those easily. And finally, I put a larger hole on top for the head of the screw, and that goes down to within about 5mm of the bottom. So there's 5mm on top, and then 5mm it screws in. These are the registration points. I just extruded those out about 2mm, and then because this is built on top of the bottom part, I then use a combine, and what I do is the top with those registration points will cut into the bottom. So the target body's the bottom, the tool's the top, and a cut will cut that groove for those registration points in. Now that is exactly the same size as the top part, which you shouldn't have. You should offset those a little. So I highlight every face and offset it a minus inset just to make it a little larger, so that will easily fit together. Now we'll look at how I sliced this. Pretty easy. There's not too much to the slicing. This is the top and bottom. I use 0.2mm layer height. I use PLA. It takes a long time. The infill is only 15%. It's certainly all you need. There is lettering on the bottom. If you don't want to make it a different color, you can just leave it as is. But if you want a manual film slot, now this will work on anything which is a derivative of Prusa slicer. Cura is a real pain to do this type of thing in, but you basically move the slider on the right hand side for a layer until it just covers the lettering. You click on the right hand side, go up about 3 layers, click again, and in between there will be a layer change. Now I'm just going to manually change the color of these so it's sort of the same as it starts. And so for 3 layers, I'm going to make this black. You'll put in a black filament. So I'm using a Prusa MK3S Plus, and there'll be 2 filament changes. It'll start in one color. I use gray. It'll stop and beep. I put in black, and then that works for 3 layers, and then it'll beep again and stop, and I put in gray and it finishes. And that's what it'll look like. The parts themselves are pretty well the same. You can use 3 perimeters here if you want, but this is fairly large. I just use 2. For the pieces, I tend to use 3 perimeters just to make them a little more solid, give them a little more heft. And you'll notice that this takes about 90, almost 100 grams of filament and 7 hours. If you have something which has input shaper, you can probably shave that down to 3 or 4 hours. Even on my Mark III S Plus, I run at about 120%, so that'll cut down to about maybe 5.5 hours. Now, it can take some time to learn a puzzle. The joy of puzzling is not to just get it done, enjoy the journey. They're really neat things, and mastering the assembly and disassembly is really, for me, the enjoyment of doing these puzzles and seeing how they work together. So I don't recommend you watch this video, but if you're starting out, or if you truly get stuck and you're trying to build up your skills, you may it helps sometimes if there's a video that can show you how to do this. So I've included a disassembly video as well, so you can watch that, but be warned, I do not recommend you watch this. You should at least work on this for a week or 2 just to see how it works. You'd be amazed what happens overnight sometimes when you're solving puzzles. So you want to get these white pieces brought down to the bottom. And there's one move at the start that you'll be making over and over again, and it involves the green and the red pieces here. So the top green pushes through, the red will move up so that you can push the bottom green through, and then you'll bring the other green piece back. And that will allow you to take that white piece on the right hand side there and push that most of the way down. Now you can get it a little further down, but you've got to repeat this process again because it's getting stuck now. It went so far down, but it's gotten stuck on that bottom green piece that you've pushed forward. So now we're going to bring it back. So we're just going to reverse what we did. As soon as you bring this back, you'll hear that thing pop down a little bit more. Now there's a red piece on the side that you want to move in, that one there. Eventually you want to move the other white piece down. And you can push this in a little bit, but that white piece, now that you've moved that red piece out, that white piece should fall right down if you wiggle it sort of back and forth a little bit or move it over. Now our goal is going to be to get the green piece that's on the bottom all the way, or most of the way forward. So you'll see some of the steps that I'll use for that. But I have to bring that red piece backwards that I just put forward. So try to make some room by moving the white piece over, so we can bring that red piece back. And now the only thing holding the white piece on the right hand side from falling out is that it's resting on the bottom green piece. So we're going to move the green piece in, and we're going to move it over to the left. You'll see how that is. But we've got to move the 2 white pieces up a bit so that the green piece can slide underneath of them and all the way to the front. We're going to move this. Now there's a little notch in that green piece, and we're going to move that towards the camera. And that's going to free up enough space that the white piece in the back is just going to drop out. So you move that backwards a little bit, or sorry, to the right. And there's a little piece of green that Yeah, slips in there, and as that moved towards me, that white piece just fell out. The red piece falls out, and the rest is trivial to now take apart. But it's hard to assemble if all the pieces are there, so unscrew the top, put them all back in, and start over again till you master the disassembly.